Okay, so yeah, well, final lesson numero seis, number 6, and this one's going to be on smart contracts. So we're going to do a little kind of introduction on what is a smart contract. It might be a term that you've heard before. What can they be used for? I mean, they can really be used for a real scope of things, quite a lot of different use cases, pretty much as wide as you're willing to build with them. Where to look for help, and then actually building a smart contract. So the programming language which we use to write smart contracts. Obviously, there's different programming languages you can use, but we're going to be using Solidity. That's the same smart contract language that you use for Ethereum and the EVM. And then we're going to be uploading the smart contract to the Hedera Hashgraph, storing it on the network, and finally interacting with it. So that'd be calling it and executing it. So firstly, what is a smart contract? Now, smart contracts are essentially what they are is they're just bits of code which live on the distributed ledger, and because obviously they're a block of code which is on this distributed ledger, then they have kind of all the benefits that come with things like blockchain, like it's immutable, like the code itself is immutable, it's verifiable, and pretty much accessible by everybody, unless the smart contract within itself has particular rules to say, right, only a certain person can use it. But so yeah, they're autonomous. Every smart contract is kind of unique, and it will have its own ID. Whether it's on the Hedera Hashgraph, it will have its own smart contract address. But with Hedera Hashgraph, it has its own smart contract ID. They're self-executing. So what that means is that you don't need a script to run a function. And what I mean by that is, let's say we go over to our code.
I was just going to say, are you sharing your screen on the call?
Oh, no.
Sorry. Oh, you're not. No, I just wasn't sure if it's the internet connection. Like, I'm just following through the slides. So, okay, cool.
No, yeah, that's annoying. I wasn't sharing my screen.
All right, cool. That's fine.
Okay, I'm just going to do a little kind of brief overview again, just for the. Right, so yeah, this is the contents of the lesson. So it's going to be an introduction into what a smart contract is, what they can be used for, where to find information about them, particularly on the Hedera Hashgraph. Building a Solidity smart contract. Solidity is the programming language which we use to create smart contracts, both for the Ethereum network and also for Hedera Hashgraph. Then you need to upload it and store it on the Hedera Hashgraph in order to be able to use it. And finally, we're going to be interacting with it. So what is a smart contract? Essentially, a smart contract is it's just a block of code which lives on the blockchain on a distributed ledger, and with that has all of the benefits that stuff on the blockchain or on the Hashgraph or any other distributed ledger has. So they're immutable, they can't be changed, and also they're very transparent in terms of they can be seen by anyone. Not necessarily acted on or called upon by anyone, because that depends on how the smart contract is written itself, but everyone can kind of look at it and try to call it. So yeah, they're autonomous. Every smart contract is unique and has its own contract ID. On Ethereum, it would be a contract address. They're self-executing, and yeah, what I mean by that is you don't need a script in order to call a function. So over here in our JavaScript code, whenever we write a function, we kind of have to then write down main. We have to invoke it over here, whereas it's slightly different in terms of smart contracts. So with that, you can get them to call once a condition is satisfied. And as I kind of briefly mentioned, they're transparent. So they're because they're on the distributed ledger on the hash graph. You can basically, anyone can look at it and anyone can check it. Anyone can make sure that it's all legit. And yeah, what can they be used for? Now, there's genuinely a massive, I mean, it's basically what can't they be used for would be an easier question to answer. But what kind of a lot of people describe smart contracts to be is essentially a replacement for the middleman. So the smart contract can kind of act as a middleman where places in places where typically a person would fill the role. And a use case or an example which I hear quite frequently is actually, let's say you've got a house and you want to sell the house, you need to transfer the ownership of the house, obviously in exchange for money. Now, when you do this, you need to go through lawyers, you need to go through intermediaries who are able to change the ownership of this property or of whatever. But essentially, with a smart contract, if you've tokenized a property, and that property is verifiably like that represents a token of a bit of land you have, let's say, you can use a smart contract to receive the token or the house, and also to receive the funds. And only once these conditions are met, i.e., you've received the house and you've received a minimum threshold of an amount of money, then will the exchange take place. And the smart contract deals with all of that. So that kind of makes it the process quite a bit cheaper. I don't know. I've never sold a house, but I can imagine the fees involved are quite substantial. So that's just one use case. I mean, for example, they're used all the time in decentralized exchanges. So a popular one is on Hashgraph is SourceSwap. SourceSwap's really cool. Now this is when I go to, for example, provide liquidity. I want to provide some, let's say USDC and it's my Wi-Fi so bad. So yeah. So let's say if I want to provide liquidity, then I've got to associate first. But this is all doing the smart contract. So if I share an example, and this is obviously Hashpack. Now if I want to supply liquidity, you can execute the smart contract, and this is engaging with a smart contract which SourceSwap have created. So we can even have a look at this particular ID. So let's have a look and check it from there. But if we go on to Hashscan, it's not on it's in the mainnet. And there we go. So this is all of the, I think this was me just now. Me did a token associate. Contract ID, so there's loads of contract calls. Again, this all of the information about people interacting with it is also public. So I mean, I'm just waiting for the day where you can do some data analytics and have a look at stuff, and it would be really quite powerful. But I mean, I've seen that. Okay, look, account whatever has provided this liquidity or whatever. You could even probably see the bytecode somewhere. I don't know where it would be, but you can see the bytecode, and then from there have a look at the smart contracts. I know that SourceSwap they've made their smart contracts all open source. But that's two examples: decentralized finance and property. Can anyone perhaps think of another use case that they've heard of for this technology, for these smart contracts?
I was just going to say buying a car, but it kind of falls into buying a house, I presume.
Well, it's the same, yeah. Anything tokenized where ownership is important and needs to be held accountable. Where, like for example, owning a car, exactly 100%. That's completely a use case. Dylan, have you heard of any other kind of uses for smart contracts, perhaps?
Yeah, I think like IoT maintenance of vehicles, like they'd send you out a notification that the car needs to be serviced, and then you could execute a smart contract to bring the materials to site when you acknowledge that you're coming to the garage or something like that.
For sure. Yeah. No, definitely. I think actually saying that a lot of Internet of Things stuff could definitely be leveraged and use smart contracts for that type of stuff. Yeah, definitely. That's quite interesting, that. Yeah, when like I said, it's really what can't they be used for, because the scope of it is just basically as creative as you want to be. As we'll get onto in a bit, we'll see how smart contracts are built. But if it's built by programs, by coding, you can basically leave it to the imagination as to what you want to build. So yeah, you can have a look at this link over here, see if you want to look into it a bit further. This link shows you how to create and transfer an NFT using the smart contract service. We've done this with the Hedera token service, but you're able to do it with smart contracts. And yeah, let's get into what we're going to do. We're just going to keep it very simple because obviously we're doing Solidity, which is a kind of a new programming language. So the first thing that we need to do is we need to create a smart contract. Now, the way that I typically like to write my smart contracts is in Remix. So Remix is because it's remix.ethereum, but it doesn't matter because it's the same programming language. So I like to use Remix. Now, the smart contract can be found in the over here. So you can also write them in Visual Studio Code. But the reason why I like to do it in Remix is because you're able to get the bytecode. So if, for example, I create a new smart contract, oh, it's still here. Okay, there we go. So this is the smart contract which I wrote earlier this morning. So a very, very simple smart contract. So you start off by, and I'm not going to go into too much detail about Solidity, but I will kind of briefly explain what the different aspects within it are.
I was just going to ask quickly.
By,
I might sound really stupid, but or I might have missed it on another. But what is Solidity?
So Solidity is the programming language used to write smart contracts. It's not, we haven't covered it before.
Okay, cool.
That's all Solidity is. So we've got, as you can see here, we've got a .sol file, .sol. When we write JavaScript, we do a .js.
Yeah.
So yeah, Solidity is literally just it's another programming language. It's like Python, it's like C#, it's like C++.
Cool. I didn't know if it like had anything to do with like liquidity or like stuff to do with financial. That's all.
No, nothing to do with liquidity. I don't know where they've got their name, to be fair. Right. So anyway, yeah. In the contract, we've got this. Yeah. So we've got this first line, which is just the license. Then we're specifying which version of Solidity we want to use. So we're using basically any version between version 7 and version 9. Then we have the name of the smart contract, which I've just called test contract. Now you can call this whatever you want. I don't know whether it's convention or it's a necessity to capitalize it at the beginning, but I always do anyway. And then we've got our function over here. So one thing which is different from Solidity compared to things like JavaScript or Python is that it's called statically typed, which basically means whenever we declare a variable, let's say I want to declare a variable called name, I have to specify what type that variable is. Now, what I mean by that is there's different types. There's numbers, there's booleans, which is true or false, there's strings, there's arrays, etc. So let's say I wanted to declare a type called a string, called name. I'd have to say string name, and then I can specify what name it is. I could say, right, okay, Thierry. And then when I save it, it will be all right. If I was to say an integer called Thierry, it probably cause an error. Yeah, there we go. So type literal string is not implicitly convertible to the type of the integer. So that's one thing which is different between Solidity and some other dynamically typed languages. So over here we've specified the input, and yeah, what the function is just going to be returning a string. So we've said, okay, the input is going to be a string, and we're going to return that input. Now this is kind of pretty irrelevant. So it's public because this function will be accessible by the public. If I was to say private, then only functions within this smart contract can reference it. The average person won't fall. No person will be able to call it from outside. So that's why it's public, because I do want people to call it. It's pure because nothing, this doesn't change anything within the smart contract. It all just is the same. There's no variables being changed. And then, yeah, we're saying that we return the string. So that's what we're doing. We're literally just entering a string and we're returning it. And if I go to run it, which you can do over here, we can deploy the contract. And over here, I can put in my string. So I might say this, or just do hello world, very, very common string. Hit return, and then there we go. It returns hello world. If I was to say boohoo, boho, it will return that. Now, this is all very good, but it's not deployed anywhere. It's not up on any sort of network, and obviously we want to get it up on the Hedera Hashgraph. So what we need to do with that is we need to go and look at what's called the bytecode. The bytecode is just basically a compiled version of this smart contract into a form which computers and virtual machines can process. So basically all of these lines here just get transpiled and they get converted into this code over here, this just massive long string. And it doesn't look like it, obviously, it's not very human readable, but computers love this stuff. So this is basically what this Solidity file is converted into a bytecode. And from this particular string, we're able to actually upload it onto the Hedera Hashgraph. So again, this isn't the code that we're going to be doing. I just want to show the process. We're going to be doing actually the code where you interact with the smart contract. But yeah, as you can see, we've got this function over here, upload smart contract. And what it does is it takes that bytecode from over here. I've imported this file into a local kind of host, and then we just do our normal.
Sorry, Jack, can you just go over how you imported the how you changed it to JSON there? Because
Right.
I've got it as a sol file, but I don't know how to get it into JSON file.
Right. Okay. So that's because over. Are you in Solidity at the moment?
Yeah, I'm in Solidity at the moment.
Okay, cool. Right. So in your firstly go over here in Solidity compiler and then press or just you can just do Control S over in your Solidity file. Hit Control S.
Okay.
And is there been like a tick now next to this sign? Compilation successful.
Yeah, there is. Yeah.
Cool. So if you go into artifacts within the contract directory, if you go into artifacts, you'll be able to see the test contract.json. This automatically gets compiled.
Okay.
So what you can do is you can then just copy all of this code. Just click on it, hit Control A, then hit Control C, and you're able to go over into your
It should be called test contract.json. Is that right?
Yes.
Okay.
Yes, it should be called that, exactly. Yeah.
And there's quite a lot of code there. Do I need to copy all of that?
Well, no. The only important thing actually is the thing which is the object. So this thing over here.
Okay. That's on line what?
Data on line 37.
37. Oh, okay. Yeah, I see what you mean now.
So yeah, if you copy and paste that particular code.
So just that long number, is it?
Yes, yeah. There's a few letters in there as well.
Okay, and then you bring that into Visual Studio.
Yeah, but look, to be honest, like I said, I'm not really going to focus on uploading the contracts. Because the contract's already been uploaded. All of you guys can now interact with it because I uploaded it earlier today. But if you'd like to, obviously you're more than welcome to. But essentially, the way that you do upload the smart contract is, so we do kind of our normal stuff. We've got the account ID and the private key. Make a client out of that. We've imported a contract create flow. So this is the class which we're going to be using in order to upload it. We've got a function over here, and then we're just creating a transaction. So we've got a new contract create flow transaction. We set the gas. The gas is basically, I mean, you know how like a car needs gas to move. smart contract needs gas to upload and to execute. So it's just basically the thing which powers these smart contracts. And then over here, we're setting the bytecode. So Dylan, if you are following this, you can just kind of copy and paste the bytecode in there like that.
Oh, okay.
So yeah, you'd be able to do that, and then you'd have the same thing up. But like I said, I'm not even gonna run this because I've already run it. And then yeah, so you submit it again, like we've already done. So you submit it, execute it with client, get the receipt, get the contract ID from that, and then we just console log out the contract ID. But what we're going to be doing is we're actually going to be calling, and we're going to be engaging with this smart contract, and we're going to be calling this function, this test.sol function, where we return our string. So that's what I'm going to be doing, and that's what we're going to be coding. So let's open up kind of the file that you've got. Now we'll just be creating a new file. So it's going to be coolsc.js. And what we're going to want to do is we're going to, so yeah, just do our kind of our basic stuff, which is look at what we've got over here in the atomic swap file, or for you, Robert, maybe the mint NFT. Did you do NFTs? Were you here for the NFTs?
Nah, that was the first one I missed. I'm actually really mad at myself that I missed that one because I was super interested in NFTs. No, I didn't get that one.
Basically, as you can see, all of kind of the beginning lines of code is the same for all of the things that we have. And obviously this could actually be made better, because we could make a file which basically just has this particular code. And then we can export that file, and you can do what's called modularizing it by creating one block of code which can be reused. What we've been doing, which is just copy and pasting the whole thing, and each thing is slightly flawed. But yeah, what you want to do is just go to kind of the send transaction, copy and paste the first 10 lines or so, and paste that into your cool smart contract. SC so conditioned to be Snapchat. And we're not going to be using the transfer transaction. What we're going to be using is we're going to be using a contract call query. I believe that's it. Contract call query. And we're also going to need to import contract function parameters. You'll see what this is later on. But yeah, essentially the contract call query is what we're going to be doing in order to call the contract and return the value that it gives us. So now that we've kind of got the main setup here, we can now go on to building our function. So we're gonna just call it cool sc. So let's say async function. It's going to be cool sc. And the first line will just be a transaction. So we're going to be building a transaction. We're going to be building a contract call query transaction. So we're going to say, right, const transaction equals new contract call query. And we're going to be setting the contract ID. Now the contract ID, I've already created the contract. So I'm going to paste in the contract ID.
Sorry, mate, I was just trying to I was just looking at where we were at new contract call query. All right, cool. Sorry.
Yeah, so contract call query, import that from the Hedera Hashgraph SDK. Now I'm going to copy and paste this into the chat. So yeah, I've copied and pasted what the contract ID is. And then what we can do is we can just set the contract ID as contract ID. So this contract I use the code which I just showed. I use that code in order to upload it onto the Hedera Hashgraph. And yeah, this is the contract ID that it created. So this is the one that we're going to be referencing. The next thing that we need to add is we need to set the function. So the function that we created, that's just basically what the name of the function is over here. So we've called it return string. So that's what we're going to specify. We're going to say, right, okay, set function. and we are setting the return string function. That's the function that we want to call. So that's the function that we want to call. Now notice that over here in this smart contract function, we've got an input argument. We're inputting a string. So what we need to do over here in the code is we also need to give it an argument. We need to say, right, new contract function parameters, and that's why we've imported this contract function parameters thing, because this gives us kind of the right format in which we need in order to add a contract parameter, add an argument. And we're going to be adding a string, and this string can be whatever you want. So I'm just going to say this is the final Hedera lesson. Now, literally, you can add whatever string you want. You can make it longer, shorter, whatever. You can add numbers. You can say 0, 0, 0. It doesn't matter. It's still reading it as a string. But that's what we've done. So we've set the function, we've set the return string function, and we've said, right, new contract function parameters, and we've passed in the first parameter. If I was to create a function which had 2 parameters, let's say the second one was an unsigned integer, and it was called my bin. If the function had 2 parameters, what we'd have to do is we'd have to then set a second one, and we'd have to set the second one, we'd say add uint 256, and then we'd specify the uint. A uint just means unsigned integer, so a positive integer, anything 0 to 10 to the power of 202 to the power of 256 minus 1, I believe. And then we could set it like that, but obviously we haven't done that with the function. It's just got one argument. It's just got the add string argument. So this is the transaction. We're then going to be submitting that to the network. So we're going to say const submit equals wait transaction dot execute. We're going to be executing that with the client. So the client that we set up over here. This client is going to be paying the fee. Oh, one thing that I think I might have missed. Maybe we need to set the gas. Just reference the previous client. Yes, we do. Right, yeah. So that's one thing that I missed. So like I kind of mentioned earlier, when dealing with smart contracts, you need to fill up the smart contract with some gas in order for it to do anything. So 100,000 gas should be more than enough. Note that gas isn't HBAR. It's like a different currency. It's basically like how in the real world, again, I'll use the car analogy, but when you fill up your car with petrol, you pay for it with pounds and you receive the petrol. This is kind of what it is over here. So we're basically saying, right, okay, we're going to pay for it in HBAR, we're going to receive gas, and the gas is what makes the smart contract function. So that's basically what it is. A smart contract, yeah, you can view it as kind of a vehicle for doing something. So 100,000.
The gas is in GUI, isn't
it? GUI is a subunit for the Ethereum.
Of Ether, yeah.
So, but no, it's still different. Like one GUI isn't one gas.
Oh, okay.
Yeah, so the price on Ethereum, the price of gas is very, very volatile. It's priced in Ethereum, but it changes a lot. It's down to supply and demand, which is why people say that the gas fees on Ethereum are unpredictable, because it fluctuates so much. It depends, and just like kind of a normal market, like when a lot of people want to use gas, the price in Ethereum goes up, so therefore it becomes more expensive. If you want to get something submitted and executed onto the Ethereum network, you either have to wait longer or you have to pay more gas. So,
is that gas measurement there? Is that in tiny bar, or is it in a different currency altogether?
It's in gas.
Oh, okay.
Yeah, so it's in the kind of gas currency, and then it's then, depending on the market, it's then exchanged for HBAR. So HBAR is what you'll be sending, but the gas, I think on you can probably have a look on the Hedera Hashgraph site. But I mean, one of the marketing points of Hedera is that the gas fees are predictable. Let's see if we can have a little dig on the site for resources. Smart contracts might be some information over here. Fees, efficiency. So yeah, smart contracts run at lower cost with less volatility. It's not telling us about the price though. Oh yeah, there we go. So yeah, so this is how it's priced. So there we go. Yeah, if you're if you're interested, this is the price of the gas. So it's pretty cheap.
Yeah, it's pretty low.
Pretty cheap. 2 million gas is 10 cents, 11 cents, 12 cents.
It's only cheap on Hedera, isn't it? Because I seem to remember you saying that the gas prices for Hedera is cheaper than what it is for normal Ethereum.
Yeah, exactly.
So I seem to remember when I was looking at NFTs, not that I had any understanding of what I was looking at, but I remember if you wanted to buy an NFT that was like $200, for example, the gas price could be like 15 or 50 or whatever, like
Exactly.
on top.
And the thing is as well with that, for example, right, okay, you can pay 15, but there's a chance that your transaction won't even go through because it just won't. People will mine the transactions with higher gas, but it's all kind of changed now that Solidity is working on a proof of stake kind of consensus model. But yeah, I mean, basically, like, yeah, you have to pay a stupid amount of money in order to mint something which is already quite a lot of money.
One of the things I was going to quickly ask, I'm following obviously everything that you're typing in here. I don't know why after contract function parameters, my brackets are purple still and yours are blue, but I don't know if that makes any difference.
Probably not. All
right, cool.
As long as there's not a red line or anything, it's all right. You've done that, and then you've got a add string underneath, yeah.
Yeah, add string is as far as I've got so far, yeah.
Nice, cool. So then, yeah, next you want to be submitting it, executing it to the smart contract, executing it to the Hedera Hashgraph. Then we can get the receipt. So we can say const receipt equals wait submit dot get receipt. No, I take that back. So actually, this is slightly different to other transactions because this is a contract call query. So actually, what essentially all we're trying to do here is we're just trying to return this value. We're just trying to get back this value which we had. So actually, what we're going to be doing is we're going to be saying, right, this is our submission, and what we're going to be doing is we're going to be getting the string in position 0. And I guess we don't even need to await it. So yeah, there we go. This is the returned string. And now we can just we can console.log that. You can say console.log return string. Then we can display that. We can say, right, return string is that. And now if we call this function, call sc, we invoke it. What we can do is we can then say, right, node, call sc, hit enter. And there we go, return string. This is the final Hedera lesson. So we can really change this to whatever we want. I'm just like that. And if we run the function again, it's going to be calling the function, and it's just going to be returning what we wrote. Obviously, this is a pretty rubbish use case of smart contracts because you're spending money in order to receive something which you're putting in, so it's kind of pointless. But it's just a little taster of what they are. I mean, yeah.
Just a question for you there, Jake. In the GitHub repository, you put a plus in front of return string on line 26. Does that make a difference?
No, it doesn't make a difference. So yeah, you can do plus or I'll explain briefly what the difference is. So okay, so let's say we have right. So let's say we've got a this I'm just gonna comment that out. So let's say we have right. Let's say we've got return string and then 54, and if we have returned. The difference is that basically when you do a plus, what this will do is that I think it will convert this 54 into a string. However, a comma keeps it as the types are separate. So if I go to call this function now, oh, I didn't save it. There we go. So the plus has converted this 54 into the type of a string and done it like that. Whereas over here, when we do the comma, it keeps them as their own types. So this is return string, and this is a number 54. Now, over here with the return string line, it really doesn't matter because this return string is a string anyway. So it kind of it's a string and a string, so it will combine it. But if, for example, we're returning like a number and we want to have it in a string format, then it would be more applicable to do a plus because then it concatenates it and creates it as one string. Does that make sense?
Yeah, that does. Thanks.
Right. Have you guys been able to do it? Did you get a return value?
Yeah.
I was just say, how do you execute it again?
So what you want to do is you want to go into your terminal on the top, hit new terminal.
Hold on. Okay, terminal, new terminal. Yeah, cool.
And then that will pull up the terminal at the bottom or maybe to the right.
Yeah, it's on the bottom. Yeah.
Yeah. And then what you want to do in here is you just want to type node, and then you want to type in the name of the function, which for me is callSC. Hit enter, and it will run.
I think there's going to be an error because I've got my callSC as always, nothing new here. My callSC at the top is in red, so.
Okay, so yeah, so there will be an error indeed. Where does it say on the over here in the top right? You kind of get like a panel of where the red line comes from.
Yeah, it says there's three different lines. Require at hash. Oh, I didn't copy and paste that number in that ID number, I don't think.
Yes, so you need to copy and paste the contract number, contract ID.
Cool, hold on one second.
Because if you're just saying, so let's say that doesn't exist, and then you're trying to set the contract ID as a variable which doesn't exist, it's basically like, okay, set contract ID null, like it doesn't exist. So we need to declare the variable before. We need to say that, okay, contract ID equals this, equals 0.0.489788135, and then we're able to do the stuff.
I've just checked and it's wait, should I just share my screen with you?
Yeah, sure.
Do you want me to do that? Yeah, all right,
yeah,
cool. This one, yeah. Cool. Let me know if you can see it. I've got it in there.
Yes.
I checked. So like I got red up here.
Okay, right. So there's one because hover over that client.
That client. What
number?
Red
line underneath it. Line number 5.
Oh right.
Hover over it. So yeah. So there's, what does it say?
So it needs to say Elias, sorry, client.
No. Look at just above view problem.
Oh, well, it needs something expected.
Yeah, comma. So comma's expected before that. So if you click off it, after contract function parameters,
yeah,
you want to write a comma.
Okay, cool.
So yeah, because it needs to have some sort of like separation between the things that you're importing.
Oh yeah, this one has it. Yeah. Okay, fair enough. Yeah. All right, I wouldn't have. Yeah, it's small. I wouldn't have. That's easy to like miss. All right, next one is under the yellow. Oh, so that'd be this one.
Okay.
This is the problem I've got. The blue. These are supposed to be blue on your screen.
Right. So So you see that bracket which is after return string?
Oh, this one here.
Yeah. So delete that.
I've closed it.
Now,
Oh, okay, cool.
Go to the end of line 20.
Yep.
Now do a close bracket there.
Even though there's one already there.
Yeah. So now you can see there's like a square box over the brackets which you've closed.
Oh, what here? Oh, right.
Yeah.
Right.
So that's because this is like the outer bracket, and then the brackets inside correspond.
Inside, yeah. I figured it was that because I've added this one in myself. Like this thing wasn't here earlier. I added it in because I noticed you had one. But I noticed you had a purple one at the bottom always, and I had absolutely nothing here.
Right. So, okay. Yeah.
I don't know why it disappeared, but I guess I didn't. All right, cool.
Okay. So there's another thing. So this also, yeah. So delete those.
These are just the extra brackets.
Delete those. That will cause an error. Cool. Right. Okay. So this won't work either.
Oh. Okay.
But okay. Look at what looks a bit. Look at line 23. What does something look a bit different about that line?
The submit isn't purple. Don't know.
Maybe something kind of it's an aesthetic thing. It's to do with color, but it's to do with what kind of looks like it's.
Okay, the return string is not the same as the submit,
right? Exactly.
Actually, I remember this. I remember seeing this. Yours is white, right?
No, mine was the same color as your submit.
Oh, okay.
As the submit above it, because the difference is that you've actually used the submit above it. You've declared the variable and then you've used it. As you can see over in the comment, it says this variable is declared, but it's never been used. So it's basically been pointless. Now, where have you tried to use it?
So like, where have I put return string? I put it down here.
Yeah, but how have you spelled it?
Oh, I copied it off your screen actually. To be fair, you all said return.
So there we go, and now you can see it's been coloured in.
Yeah, cool.
So okay, so
it's actually funny when I pressed tab to like auto insert, it chose return, and I wondered why it did that because yours says returned.
Yeah, exactly. It's because you typed it in initially wrong.
Well, so this one, like it can be anything, but I did it different to what you did it, and then I did what you did. All right, cool. So
exactly.
Do I need to delete this, or I need to save it?
It's the same thing, but I mean, you've also capitalized the C there.
Oh yeah, fair enough. Oh shit, how do I delete it?
I think you've done some funky stuff. But hit enter.
Okay, cool.
Hit enter again. Oh no, okay. Right. Aha. Yeah. So your add string wasn't capitalized. It needs to be add and then a capital S for that add string, line 20.
Line 20, all right. Oh, it's even got like red dots. Oh, this needs to be capital?
Yeah, no, capital, just the S.
Just the S.
Well, nope. Yeah.
Just the S.
Oh, the S. Oh, right, my bad. I thought you said yes. Okay, cool.
Fair enough. Right, hit save, and then that should all be positive.
Cool. So if I try, then I
press up. Press up on the keypad.
I just corrected the C, yeah.
To be honest, I think it will run anyway, but yeah, it should be able to get into now.
Cool.
There we go.
All right, nice.
Boom. Just interacted with your first first Hedera Hashgraph.
I seem to always have a problem. I don't know, like I messed it up every time. There you go.
Oh no, I think most people have problems. There's times where I do the same thing.
I was gonna say it's quite admirable, like how knowledgeable you are on coding, because this stuff is hella complicated.
Bro, I've done this honestly hundreds and hundreds of times, but there's a lot of people who make me look like an absolute buffoon for sure.
I mean, one of my other mates his job is a coder, and he's going through all this stuff on Instagram where he's posting about it, and it's just like, what am I looking at?
Yeah. Do you know what language he programs in?
To be fair, I don't know, but I can always send you his Instagram to you, and you can
send it over, bro. Send it over. Right, I'm gonna share my screen again.
Fairness. Yeah, perfect. Thank you for that.
But yeah, no, that basically sums up kind of the whole 6-week little course. So yeah, we created this contract, uploaded it, interacted with it, executed it, can view the transaction, but you can do it in your own time. So yeah, thank you very much.